Okay, let's do problem 106. Construct a binary tree from Inorder and Postorder Traversal. So this question is exactly same as question 105, except this one has pre-order and the 105 had, this one has post-order and the 105 had pre-order. So the only difference I can think of is because pre-order, okay, let's see what, so I keep saying pre-order. So pre-order is root to left to right, but post order is left to right to root. Yeah, it would kind of make sense to have arrow this way. So in pre-order, we were incrementing the pointer of pre-order, but in post-order, all we need to do is just decrement the pointer of post-order, and we are going to create a hash map just like pre-order. And the only thing I can think of is inside this private tree node build function. In pre-order, we did create the left one first, and then we call the right one. But here we need to get the right one first because we're going to start from the right and then decrement the pointer one by one. So let's do it. So we do need a pointer for post order. Post index. It should be post order the dot length -1, but we need to define that here because we don't have any information of post order outside the function. And then we do need hash map. And the edge cases are still the same. If Inorder is equal to null, or post order is equal to null, or Inorder dot length is not equal to post order dot length, we return null. And then we can define our post index here, post order dot length -1, and then we can do for int I equals 0, I is less than Inorder dot length, and then I plus plus. It's literally the same question. You can do Inorder index dot put Inorder I and then I, and then we need to return build. We need to put in post order and then in L and R, which is 0, and Inorder dot length -1. So inside our build, we do need integer array of post order, int L and then int R. Because the post order starts from the right, that does not mean that this condition where L is greater than R return null. So this one shouldn't change, still the same. And then we get int root val, which is post order dot post index, and then we create root based on this root val, and then we find the midpoint using a hash map, So Inorder index.get root file, and then instead of calling right, left, we need to call right first. Also, we have to decrement it rather than incrementing. So that means root.right is equal to build post order, and then mid plus 1 still remains the same, and then r, and then root.left is build up post order L, and then mid minus 1. So we had that before root.right for pre-order, because it starts from the left, and then return root. Okay, let's run the test. Build post order. All right, let's submit. Okay, that's it.